Ahí le pone.
El proyecto de investigación Info Project y la carrera de Ingeniería en Tecnologías de la Información de la Universidad Nacional de Chimborazo, Ecuador, te invitan a participar en Second International Congress Innovation Research and Technology in Information and Communication Technology, ICTOR 2022. Evento virtual a realizarse del 21 al 25 de febrero del 2022. Para más información, visita nuestra web ictor2022.unach.edu.es.
La carrera de Tecnologías de la Información surgió por la necesidad de contar con profesionales que ayuden al desarrollo sustentable de la sociedad en el campo de tecnologías de la información.
Estudia los principios, metodologías y estándares de calidad involucradas en el proceso de análisis, diseño e implementación de las tecnologías de información en un organismo institucional, en las áreas como son redes, programación, infraestructura, seguridad, base de datos y servicios web, lo que contribuyan al desarrollo productivo, local y nacional, así también como el acceso universal a la información y comunicación.
El objetivo de la carrera de Tecnologías de la Información es formar profesionales éticos, competentes y emprendedores con conocimientos prácticos y teóricos para diseñar, implementar y evaluar soluciones de tecnologías de la información. Otro de los objetivos de la carrera es permitir el acceso al conocimiento científico que es necesario para desarrollar las competencias profesionales que contribuyan al desempeño laboral en las áreas de redes, programación, seguridad de la información, infraestructura, desarrollo de software y aplicaciones web.
La Universidad Nacional de Chimborazo nos brinda varios servicios como son el uso de laboratorios y equipos de última tecnología, acceso a la plataforma, aula virtual y biblioteca. Tenemos también áreas verdes y espacios de recreación. Un servicio adicional, contamos con un incentivo a los estudiantes que obtienen el primero y segundo lugar al culminar cada semestre con las mayores notas. A eso lo conocemos como son las becas académicas.
Doctora, tiene desactivado el audio.
Perdón. Muy buenas tardes con todos. Muchísimas gracias por estar presentes aquí en este primer taller de este cuarto día de charlas en lo que es el IC Talk 2022. Vamos a dar una pequeña introducción de nuestro expositor del día de hoy, la doctora HIEDA Silva, acompañada de la ingeniera Alana Miranda. Tenemos como una pequeña introducción de la doctora Silva. Es profesor investigador en la Universidad Federal de Para. Es PhD in Information and Communication Engineering within the Department of Information Engineering, Electronics and Telecommunication, University of Rome, La Sapienza, Italy, 2018. Master degree in Computer Science in 2009, a Bachelor degree in Information System in 2006, and full degree in Mathematics in 2005. Project in Machine Learning, Information System, Intelligent System, and Deep Learning. Una pequeña introducción de la ingeniera Alana Miranda. Bachelor in Information System en la Universidad Federal Para de Brasil. Internship and as instructor of computer courses at the Eurodata Company. Machine Learning, Geographic Information System, and Deep Learning Researcher at Federal University of Para, Brasil. Este día van a realizar un taller con el título de una introducción a un análisis de datos con Python. Aquí será abordado cómo analizar los datos utilizando Python, abrangiendo desde lo básico hasta lo que es Python, hacia una explicación de los diferentes tipos de datos, en la que ustedes podrán aprender a preparar datos para un análisis, la ejecución del análisis, estadísticas simples, cómo crear lo que son las visualizaciones de los datos significativas y prever tendencias futuras a partir de los datos y mucho más. Entonces damos una pequeña bienvenida a la doctora HIEDA Silva y a la ingeniera Alana Miranda. Thank you, HIEDA. Thank you, Alana, to be here in this IC Talk 2022. And now I have given a small introduction, a short introduction about yours. And thank you so much to be here, and please continue. Thank you.
Microfone, professora.
Hi, everyone. My name is HIEDA Silva. We talk about today, we present about an introduction to data analysis with Python. So I live in here. Only organize because the screen is in the middle. Okay. Okay. Okay, start now. I try putting Spanish as well, because I know some students maybe can't understand very well English. So I try translation for you. No time for translation or presentation, but more important parts I put in English and Spanish. So if you can understand very well, you can read in Spanish. First, I say thank you for inviting us, Alana and me, for doing this presentation. We are really pleasure stay here and contribute with your beautiful events. So, and share this challenge, and we can talk today about data analysis with Python. Is our introduction. I don't know if all students is experienced or not with Python or data analysis. I have no idea, but we start the basic concepts and until the one implementation. Alana, I will show for you implementation, complete presentation, complete implementation in Python with one project. So I will start to show for you theory. So concept, basic concept. His outline, you can see what you see today. Analysis of, we focus today in K-means cluster algorithm. Of course, we have too many algorithms, too many methods for implementation machine learning. I don't know if you will have some classes or some discipline that talk about this, but this area nowadays, from, I believe, from more recently 5 years, too many applications we have, of course, because now all markets, all companies try apply artificial intelligence in the project. So it's really, really, really important area now. So if you want to start career in data science, in machine learning, you need to start learning all algorithms, or you need to learn libraries as well. Alana will show for you about libraries, how you can have a database for training your models, etc. So all this we have today. We focus in this algorithm, K-means, is really, really important. That is why we choose. Also, we choose one database, Iris database from Kaggle. Kaggle is one platform, public data you can have as well, is free, you can have download and analyze this data. Alana will show for you as well later in implementation. So we start a brief resume about what is clustering, because we focus in clustering, in type of clusters, what is K-means clustering, how does K-means algorithms work. I put his, I'm sorry if this translation is not very, very good, because I use a Google Translator. I hope it can help you if you're difficult to understand this English. So this is theory we have, and the practical, we use the K-means cluster with Python, use Google Colab, is a free or online, you don't need to download as well. This database from Kaggle, you can access as well. Maybe Alana can put in comments, people can see together with us this example. So first of all, I will show you the quick difference before I start K-means algorithm. I will talk about the difference between supervised learning and unsupervised learning. Means supervised learning look like when you have one professor, for instance. Remember when we was children, for instance, you have your dad, your mom, explain to you about, for instance, the apple. You don't see one apple before, but your dad, your father, show for you one apple. He say for you, this is one apple, this is one banana, this is one dog, this is one cat. So means you have one supervisor, means you have one professor. So this is supervised learning. In this case, normally you have labels for defining these objectives. In another case, unsupervised learning, you don't have a label. Means you don't have one professor, you don't have one teacher for you, you don't have one, your dad, mama say for you, this is apple. No, what you have here is one group of objects. After you need, what you see here, we see learning cluster group without label, or seja, means here we don't have label. You can use a cluster many applications in this area. So customer segmentation, image comparison, bioinformatics learning motifs, find important features. You need to find features. In this case, you have unsupervised learning because this example show is focused in unsupervised, means you don't have one professor, you don't have one supervisor. Okay, what you have then? You have one group of data, raw data. From this data, you extract features. Here you have all features. After that, you have group into classes, and then you have clustering. We show where you can use this, how important to use this, how you can work this nowadays in companies. All this will show for you in this presentation. So means no supervision. You don't have a supervision. We are only give data and you want to find a natural group. So I try put too many images. So I think it's more easy for you understand when you have one image. Unsupervised learning modeling. Most frequently, when people think of unsupervised learning, they think about clustering. That is why we choose talk about K-means clustering, because it's more common, it's more famous algorithm when you think about no or unsupervised learning. Another category, learning of probabilities, parameters for models without supervision. Learning translation dictionary, learning grammar for language, learning sociography. For instance, here in this illustration, how many clusters do you think we have here? So maybe we have 3 or 2. We don't know exactly now. We need to discover now. Remember, we don't have one professor. We don't have here one supervisor say for you exactly labels, how many cluster group. No, we choose discover this now. So maybe 5 cluster or group. Understand cluster is group. Here we have a 5 group or 2 group. How many clusters? How discover number of clusters? Now, another example here. Here I put in Spanish for you understand it better. So we have here many different animals. Are they in the same cluster? No, we need to separate it because here some animals is how animals bear their progeny, how animals dão à luz a seu progênio. E another is if they have lugs or not, means existência de pulmões. Means, for instance, fish. Some fish, I think fishes normally don't have lug. Okay, so we need to separate it in different groups. This is clustering. But remember, we don't have one professor. We need to discover this. You have one group of data, and you need to classify this. Why is important? Many application we show for you later. Why is important? Now we will answer this question. Why is important to study and understand K-means algorithm? K-means is a very famous and powerful unsupervised learning algorithm. It's normally used to solve many complex problems in machine learning area. So machine learning area, artificial intelligence is really big area for you start study, you need to go step by step. So you can start for he, for instance. Another day you can study another algorithm when you see you have a big knowledge. So here we have a three cluster or three group, okay? K-means is used in clustering tasking. What means clustering? The process of group a set of objects into classes of similar objects means they separate the similar objects. The main or the goal is to create a model and group data according to their characteristics. Okay, for instance, we can separate for instance, Brazilian people, Ecuador, US, for instance, three different groups. So the goal here is minimize the sum of the distance between the points and the respective cluster centroid. The first process for developing this algorithm is find one centroid. One point is central of the group or cluster. I try resume for you here. The number of group cluster is represented by the letter K. That is why we call K-means. So if you have two groups, K is equal to. If you have three groups, K is equal 3, for instance. It is important to correctly define the number of groups into which we want to divide the data. In situation where the value is, where K is not known, optimization methods are used to find it. Let's understand this example. Let's understand the K-means cluster algorithm with a simple example or one simple definition. A K-means cluster algorithm tries to group similar items in the form of a cluster. The number of a group is represented by K. What means he in this example? Let's take this example and pay attention, please. Suppose here you went to a vegetable shop to buy some vegetable. There you will see different kinds of vegetable. For instance, imagine you have apple. Apple is no vegetable, sorry. Let me see. You have here, okay, imagine many different vegetables. The one thing you will notice that the vegetable will be arranged in the group, in the type. Normally, when you go in supermarket, all vegetables the same section. For instance, you have the carrot, you have cucumber, you have many different vegetables together. Like all the carrots will be kept in one place. Potatoes will be kept with the kinds and so. If you will notice here, we will find them, they are forming a group of clusters, where each of vegetable is kept with the kind of group, or say, means kind of group or cluster. So now you understand this with this figure. The first figure you can see here is before apply K-means clustering. You have one group, many different vegetables mixed here. So you need to separate this. So understand here, for instance, you can have potato or carrots, a cucumber, for instance. So another step here, yes. How does K-means cluster algorithm work? Here you have 4 4 figure, okay? You have 4 figures. So let's explain all this. First figure show the representation of data of 2 different items. The first item has shown in blue color, and the second item has shown in red color. Here, I'm choose the value of the K randomly, like 2. There are different methods by which we can choose the right K values. In this figure 2, join the 2 select points. Now, to find your centroid, remember I explained before, we need to choose here centroid. We will draw here in the second figure, we draw here a perpendicular line to the line. The point will move to the centroid. If you notice, they will see that the some red points are now moved to the blue points. Now, the points below to the group of the blue color items. So now, pay attention in figure 2. I try to describe for you all process. So in figure 3, the same process will continue in figure 3. We'll join the 2 points and draw a perpendicular line to that to find out the centroid. Now the 2 points will move to the each centroid, and again some of the red point gets converted to blue point. The last step, the same process is happening in figure 4. This process will be continued until and unless we get 2 completely different clusters of this group. So here in resume 3 steps. First, select K values. For instance, K equal to, because you understood here 2 clusters. Initialize the centroid, select the group and find the average. Please note that K-means cluster uses the Euclidean distance. So they will find which one is more distance between one object and the centroid. If this object is more near this centroid, means this object pertains to this group. Understand? So, how choose the value of K? Como eleger o valor de K? One of the most challenging tasks in these problems, or clustering, or grouping, is choose the right value of K, because we don't know exactly. What should be right K value? How choose the K value? Let's find the answer to this question. If you choose the K value randomly, it might be correct or may be wrong. If you will choose the wrong value, then it will directly affect your model performance. So there are 2 methods by which you can select. Basically, we have two methods: elbow method, and silhouette method. Let's understand. I put one resume here and in Spanish here for you. Elbow method is elbow method. You can read here the resume of this. Okay. In the elbow method, you are actually varying the number of clusters. For each K value, we are calculating with cluster sum of square. In silhouette method, refer to a method of interpretation and validation of constraints with cluster of data. The techniques provide a set graphical representation of how each object has been classified. But today is more easy this implementation, because if you use Python for instance, this is only one parameter maybe you need to choose, so it's not really difficult. You understand how you choose one method, if it's silhouette method. Which one now is, I'm sure you are curious about, okay, this is really important, but where can I use this? Which one application? So real application, Google News, for instance, they classify these notices by the group. We use cluster and show for you one group of notices, for instance. Real application, genetics analysis. Em aplicações reais, or here you can use, you can see here, organize compute cluster, market segmentation, social network analysis, autonomical data analysis, or this area. Another important areas is bank, I use as well. For instance, they want to classify which one message is spam or not spam, fraud detection or not detection, fraud or not. In biology, city plan, climate change, finance, image compression segmentation, information retrieval organization, land use, marketing, and social network mining. So in all this area, you can apply, you can use this technique. This is, I'm sure you use already in social media, for instance, clustering, face clustering. I'm sure everyone here want to target one friend, when you post one picture, for instance, Instagram, Facebook. So how they do this? First, input face, initial cluster, intermediate cluster, and the final cluster, when you have hard features and classify. And now you can see here steps by steps, frame extraction. You have many different images. After that, you have face detection, features extraction, and face clustering. In the end, for instance, you can we can see many applications nowadays when you organize your pictures, your iCloud, your computer, you know, they classify your image, for instance, by country, by square. They can organize your pictures. All this they use clustering. Search results, when you have, for instance, here, if you type apples, so they have many groups of different this application as well. Clustering search advice, uma agrupação lá publicitar. Here you can find the cluster of advice and the keynotes. A simple example for you understand as well. Keynote suggestion, performance estimation. Here they separate different groups as well. In this example here, data from all customer bases divided into clusters. We can make an informed decision about who we think is best suited for this product. You can see here, these guys, they have a different group and choose which one product is more indicated for these guys, for instance. So means you don't need, for instance, send some products, some notices for some people that is not interested in some product. You can send, for instance, one product exactly for people is being interested, because you know which one thinks these people can buy or not, for instance. Let's understand this with an example. Suppose you are a market manager and you have a new tempted product to sell. We are sure that the product would bring enormous profit as long as it is sold to the right people. So how can you tell who is the best suited for the product from our company, huge customer base? So I think is this figure show you 4 clusters formed from the set of unlabeled data. So means that you classify exactly what the people need, for instance, which one is more good for sending. Intro for what the intro for clustering. Representation for clustering. How do you represent one example? How to choose these features? This is big challenge. Similarity distance between example. Flat clustering or hierarchical, which one you use as well, because we have 2 different number of clusters, fixed a priori driving, data driving. He showed this image only for show you which one different types cluster algorithm you have, flat algorithm and hierarchy algorithm. So in resume now, most well-known and popular cluster algorithm starts with some initial cluster center. This is you choose. After this, you have many iterations. Assign cluster each example to close the center. Recalculate center at the mean of the points in the cluster. Here, I think is better for you understanding this example. Small, everything with figure is better for understanding. Initialize center randomic. Look, we choose here 3 different centers, okay? Because we suppose here we have 3 clusters or 3 groups. Assign a point to nearest center. We look which one points. For instance, this point here is more near to this center. If you see this point is more near this center or more near that center, blue or red, of course, this point is more near, is less distance, okay? It is how this algorithm work. They will calculate which one distance is more small, okay, for center. For instance, this point here is more near this center or more near the center or more near this one. Of course, this point is more near here. That is why algorithm classifies in this group. But this is run many times until find the best solution. Readjust center, assign point to nearest center again. They change the center, readjust center again, assign point to the nearest center, readjust center again. So this many times until no change more. Assign point to nearest center, and now is done. So assign cluster each example to closest center. Recalculate center as the mean of the point in a cluster. So for finish this iteration, here you can see this point, for instance, they show here this point, if this point is more near blue or more near red or more near point, a pink. Iterate over each point, get distance to each cluster center, assign it to closest center, recalculate center as the mean of the point in a cluster. This is the most simple way for you to understand how this algorithm works, okay? Get distance to each cluster center, assign it to closest center, recalculate it again. What distance? measure should you use? In my opinion, this blue, small near, okay? I only for emphasizing here how they calculate this distance. They use the Euclidean formula for calculate this simple formula, no complexity. So for finish now, in summary, cluster analysis group object based on their similarity. For instance, I start to show you 3 different groups similar from their country, for instance, Brazil, Ecuador, UK, or US. So, and it has a broad range of application. Measure of distance plays a critical role in cluster analysis and distance-based learning. So some reference here after this brief theory. Now we have the implementation. I think it's more clear now when you see implementation practical in use the title with now Alana Miranda. Thank you very much.
Hi, my name is Alana Miranda. Professora, só me confirme se está ok meu áudio, minha tela. Eu vou logo compartilhar. Não estou lhe ouvindo.
Tá ok.
Está aparecendo o orange?
Ainda não, tem que compartilhar a tela.
Certo.
Demora um pouquinho, mas já tá agora.
Okay. So my name is Alana Miranda. I have a bachelor's degree in computer science from the Federal University of Pará in Brazil. And since graduation, I had a lot of affinity with the machine learning researches. So it's an honor to be here sharing some of my knowledge, even though my English isn't that good, but I hope you guys can understand me. Well, now I'll continue the content in a practical way. Today, I will apply some concepts of the K-mean cluster algorithm, first using the Orange software, and then use Google Colab with the Python programming language. So let's get to know a little about the Orange software. The Orange is an open source tool that allows you to create the entire workflow of a machine learning project without the need for programming codes. Orange has an interface with the drag and drop interactions, so to apply a certain algorithm or visualization technique, you just need to drag and drop on the screen such features. The software allows you to work with images, text files, databases, and other file formats. Another feature is that the variety of data visualization, exploration, preprocessing, and modeling techniques. You'll find several machine learning algorithms such as decision tree, nearest neighbor, and AV base. Software like Orange show us that you don't need to be a programmer to learn and apply machine learning techniques. We're going to see how this can be easy and fun. So we're going to start now to loading the dataset by dragging the dataset icon on this data section. This is my Orange workspace, okay? I don't know if you already know this software. So let's drag this to the screen. Well, you can use the dataset from Orange, or you can import a CSV file, you can create a file, you can also connect the SQL table to this. But today we're going to use the dataset from Orange, and we're going to use the iris dataset. Let's search here and select it. And let's see a few informations of this algorithm. We have 150 instances, 5 variables, and the target of this dataset is categorical. So we have classes. Let's read this description of this data set. Okay. The iris flower dataset, or Fisher's iris dataset, was introduced by the British statistician and biologist Ronald Fisher in his 1936 paper as an example of linear discriminant analysis. The data on length and width of petal and sepal leaf was actually collected by American botanist Edgar Anderson to quantify the morphological variation of iris flowers of 3 related species. So we have 3 related species, which means we have 3 different classes in this data set. So it's already selected. You can see this point here, screen point. So you can close here. And now let's see how the data set looks like by dragging the data table icon to the screen. The data table icon is here. So we need to drag it here and connect to the data set. Now just double click and we can see that we have the 5 variables. The first one is the iris variable. We have the types of iris flower, and we have the sepal length, sepal width, petal length, and petal width. And we can see that we have 150 entries here. Okay. The objective is to teach the K-means algorithm to group these flowers into three different groups based only on their measurements. Their measurements here, we don't need to use these, okay, on my algorithm. So let's close. Now let's apply the algorithm on the data set by dragging the K-means icon on the unsupervised section. The unsupervised section is here. Now let's search for the K-means algorithm. Just drag it here. It's really easy to use. Connect to the data set. Okay. Now, if you double click on the algorithm, you can change the value of the K, this one here. That is the number of clusters that should be considered. As there are 3 species of the flower, let's put the key equal to 3. So it's already here 3, so we don't have to change, just close. And now let's visualize the clusters. So we can also add the scatter plot. To do this, drag the scatter plot icon from the visualize section. Here is the visualize. The scatter plot to see the cluster. Connect to the algorithm and double click on the new icon. So we can see here that there are 3 groups with 3 different colors. In the blue one, we have the group of flowers classified as Iris setosa, which my algorithm called cluster C2. And in red, we have the Iris versicolor that my algorithm called the C1 cluster. And in green, we have the Iris virginica that the algorithm classified as, sorry, it's not showing here, but the algorithm classified as C2, C3 group. Okay, no, it's here. So you can also use a data table to see if the algorithm correctly grouped the flowers according to the species. Drag the icon in the data section, the data table, connect to the algorithm and click to view. So we have here the iris column that represents the true species of the plants. And we have the cluster table, represents the group in which each record was placed. So you can compare to see if the algorithm is working. Okay, so now we're going to do the same thing on the Google Colab. I hope you can see this. Okay, so this is the Google Colab. Google Colab is an executable document that lets you write, run, and share code with Google Drive. If you're familiar with the popular Jupyter Notebook, you can think of Colab as a Jupyter Notebook store in Google Drive. A notebook document is composed of cells, each of which can contain codes, text, images, and more. The collab connects your notebook to a cloud-based runtime, meaning you can execute Python code without any required setup on your own machine. So now let's get started. And this is our project, okay? I can share with you later the link of this so you can see. The name of this project is K-means clustering on ICE dataset. It's on Kaggle. This link here, I can pass it on the comments later. So the data set consists of 150 samples, 50 samples from each of 3 species of iris: Iris setosa, Iris virginica, and Iris versicolor. 4 features were measured from each sample: the length and the width of sepals and petals. And this is a picture of all this flower, this iris flower. The versicolor, setosa, virginica, you can see is a little bit different from each other. And in this project, we will use some Python libraries for data analysis and visualization, in addition to the K-means algorithm to classify and group the data into clusters. So we're going to start by importing libraries. A library is a collection of precompiled codes that can be used later in a program for some specific well-defined operations. So these green lines here are comments, okay? So don't be scared. All of them is not codes. Some of just comments, okay? First of all, we have to import essential libraries. We are using pandas library for data process and CSV file, NumPy library for linear algebra, matplotlib, and Seaborn. Both will be used to plot graphs. So we have these nicknames here. We import panda spd. So when we use the operation of each library, we don't have to use the full name of the library. We just call it pandas like pd. So it's a nickname of this library. So pandas spd, numpy as np, matplotlib as plot, and Seaborn as snc. So every time you see this on the code, you need to remember that it's from this library. So let's run the cell. Okay, now we need to load in the data set. And first we're going to start using this PD with CSV. And this PD with CSV reads a comma separated value of CSV file into data frame. Now our data set is on a data frame, is on a CSV file and is stored on my Google Drive. And this is the link of the data set. And this PD is calling it and reading. And this iris object I created is to store the data set. Okay, so let's run the cell. And now my data set is here on iris. So now let's check the data set using the iris.head. The head function is used to get the first n rows. Let's run this. In this case, the first n rows, the first 5 rows. So we have here, it really looks like the data set of the orange because it's the same data set. So we have the sepal length, the sepal width, petal length, and petal width. And the species, of course. But we only see 5 rows, so we can just call the iris and see the full data set. So, okay, it's here. We have 150 rows and 5 columns. So let's check the info of this data set. Okay, the info method prints information about the data frame. In this case, in my iris dataset, I want to see the information of the dataset. So let's run this cell. The information contains the number of columns. We have here total 5 columns. The column labels, we have these labels of each column. We have the column data types here. These are my data types. We have the memory usage of my CSV file, my range index, 150 entries, 0 to 149, and then the number of cells in each column. So we have 150 in this column, this column, this column, this column, and we have no new values, no missing data, okay? So let's check now the frequency distribution of species. I'm using this value counts, that is a function that returns object containing counts of unique values. Let me run this cell. And I'm doing this to my column of species, my species column. So we have here Irisatosa with 50 entries, Iris column with 50 entries, and Virginica with 50 entries. So the preview of the data is, we have 150 observations with 4 features each: sample length, sample width, petal length, petal width. There are no new values, so we don't have to worry about that. Because if you had known values in a data set, we will need to clean up this. We will need to delete this missing data to the algorithm work. And there are 50 observations of each species. Okay, the next part now is the data visualization. We're gonna see how the data is distributed. Let's apply a scatter plot to see how the data is distributed. The relationship between X and Y can be shown for different subsets of the data. Use the hue, size, and style parameters. Let's see what it means. We have here the white grid style to my plot. You're gonna see how this is. I'm gonna run this because it takes a little time. And okay, let's continue. Now we are using the pay plot that plot pairwise relationships in a data set. This function has a few parameters. Data frame, this one is the data frame parameter, where each column is a variable and each row is an observation. In our case, the data frame is iris, and the other parameter is the hue. The hue is a variable in data to map plot aspects to different colors. And this is just the size we want the plot to be. So this is the plot of the data, how it's distributed. And we can see in blue the Irisatosa, the Iris column in orange, and the green is the Iris Virginica. After graphing the features in a paper, it's clear that the relationship between pairs of features of Irisatosa in blue is very different from those of the other 2 species. You can see that the difference because the Irisatosa group is more isolated in each observation. You can see here, almost all the observation, the Irisatosa is isolated. Meanwhile, there is some overlap in the pairwise relationships of the other 2 species, Iris versicolor in orange and Iris virginica in green. We can say that both species have very similar characteristics. Okay, so now we're going to talk about k-means for a little to remember. And k-means is a centroid-based algorithm or a distance-based algorithm where we calculate the distance to assign a point to a cluster. In k-means, each cluster is associated with a centroid. How to implement a k-means cluster? Let's see once again. So we have first to select the number of clusters for the data set. Select the k number of centroids. By calculating the Euclidean distance or Manhattan distance, assign the points to the nearest centroid, thus creating k groups. Now find the original centroid in each group, and again assign the whole data point based on this new centroid. Then repeat step 4 until the position of the centroid doesn't change. So we don't have to worry about all this step because we are not going to do this. It's only the algorithm. We only need to choose the K constant. Okay, so we have the right classification of our data set, but for the purpose of this project, we are going to forget that we already know the species of our samples, and we are going to try to group them using k-means. Since we are working with an unsupervised learning algorithm, we need to ensure that the algorithm only receives the input data. In our data set, the IRIS data set, the input data is only the measurements of the plants, not the classification. So now let's slice the important features for the algorithm, our input data. We're going to use this iloc data values. The iloc in pandas library is used to select rows and columns by number in the order that they appear in the data frame. The iloc indexer syntax is data.iloc. We have the row selection, comma, column selection. Okay, so now let's see. I created this variable x, and I'm calling this iris iloc. So in the row section, I have this column here because I want all the rows of my data set, and the rows are 150, you already know. So all the rows of the data. And in the column section here, look, we have only a few columns. So let's see these columns. We have 0, 1, 2, and 3 columns. So let's check in the data set. Who are them? Okay, this is the 0 column, the 1, 2, and 3. This is the 4 column. We're not going to use. You need to remember this, okay? So we are slicing this data to this x variable. Only the values, okay? I only want the values of the measure of the plants. So let's run this. Just check here. Okay. And let's see how the x looks like now. Just have the x here. Let's run the cell. And you can see we have only the measurements of the plants. I have my variable x, only the measurements. Okay, so let me clean this. Okay, we already know that the ideal value of k for this data set is 3, since we only have 3 groups of plants. But let's see how we would do if we didn't know the value of k. In the k-means version implemented in scikit-learn, if you don't inform an initial number of clusters, by default, it will try to find 8 decent groups. But we don't want this. We want to discover we have to find the optimal number of clusters for k-means classification. A commonly used method for finding optimal k value is the elbow method. So now I'm going for this module, this scikit-learn module for clustering. I'm going to explain what this means later. So let's focus on this part of the code. Like for I in range, this is calculating the k-means for 10 different amounts of clusters, ranging from 1 to 10 possible groups. Okay, so we have now we're going to use the k-means, and it has a few parameters. This one. Now let's see what it means. The n clusters here, the n clusters means the number of clusters. So this I is in range of 1 to 10. So 10 clusters to see. And the indice here is the algorithm that defines the position of clusters more severely. In this case, we are using the k-means. The max iter is the maximum number of iterations. The n-init is the number of times that the k-means algorithm will be run with different centroids. In this case, it's 10. And random states determines the random number of generation for centroid initialization. So we have this fit here that is training instance to cluster. In our axis, we already know what it is. So it's training, it's data. And this inertia measures how well a data set was clustered by k-means. Okay, basically, the idea is to run k-means for many different amounts of clusters and say which one of those amounts is the optimal number of clusters. What usually happens is that as we increase the quantities of clusters, the difference between clusters gets smaller, while the difference between samples inside clusters increase as well. So the goal is to find a balance point in which the samples in a group are the most homogeneous possible and the cluster are the most different from each other. Since k-means calculate the distance between samples and the center of the cluster from which sample belongs, the ideal is that this distance is the smallest possible. We are searching for a number of groups that the within cluster's sum of square, this one, is closer to 0, being 0 the optimal result. Let me run this cell that I forgot to run. Okay, so let's continue. When we use the function to calculate the within cluster sum of square, this function, we use it here. For our iris dataset and plot the result, we will find a plot like this. So let's plot the elbow method here to that function. So this is an elbow method, and you can see it looks a little bit like a elbow, this elbow. And the point at which the elbow shape is created is 3. You can see here, this is the point where my elbow is created. That is our k-value, or an optimal number of cluster is 3. Now let's train the model on the data set with a number of clusters 3. So we're going to repeat the part of the code of k-means, but the n cluster now will be 3. Okay, and this fixed predictor is computing cluster centers and predicting cluster index for each sample. Let's run. Now the algorithm has been implemented. So we need to visualize the clusters that the algorithm forms. Let's visualize the cluster with a scatter plot from matplotlib library. This is the scatter plot for my 3 species, Isotosa, Versicolor, Virginica, and we are defining the colors, the size, and the data here. And this is the plotting of the centroids of the cluster. And the centroids, I want them to be red. I want the label centroids, the size 100. And this is my scatter plot. And as you can see, there are 3 clusters in total, which are visualized in a different colors, and the centroid of each cluster is visualized in red color, as you can see here. So this was the project. I hope you guys can enjoy it. And I'm gonna to pass the link of this project on the comments here. Okay, so thank you for watching, and this is done.
Okay, thank you very much. We are very grateful with Dr. HIEDA Silva and Engineer Alana Miranda for your participation in this workshop. I think many students will be interested in this area, for example, in the analysis to different data sets using Python. Now we ask the participation of the attendees with their questions, please. any participant can ask to the engineer and Dr. Silva, please. So I would like to ask you about features and data. For example, in image processing, how can performance be measured in order to reduce the error, for example, to classify different pixels?
Sorry?
I would like about classification in image, about the performance of this method in order to classify different pixels of image. How I can measure this performance?
You know, you read about this, about the image, Alana, or not? Because I know the algorithm tried this running again algorithm, how loss function, and you try the best performance. So I don't know if I answered this question, but
Eu acho que ele estava perguntando daquela parte que a senhora falou sobre as imagens, a classificação de imagens com o K-means. Acho que é só para a senhora explicar como é feito.
Yeah, they choose aleatory, like choose which one characters is more similar about the centroid, and this initially is aleatory. So, and the algorithm try define automatically the best solution, but use artificial intelligence to many algorithms is inside this is we need to maybe understand more deep about how this optimization is look like optimization algorithms for see which one characteristic is more similar.
Okay, thank you. And another question, please refer to the data. Should the data have any specific characteristic to apply this technique?
Sorry?
This question is about the characteristic of data. The data have any specific characteristic to apply clustering?
You know this, Alana?
In general, please. For example, data in economy, data in medical area, etc. Clustering can be applied successfully.
Yes.
Yes. Like I showed before, in Orange software, we have a lot of data sets. This one we were using is a biology data set, but we have an economic here. We have a lot of kind of data set with a specific characteristics. Yes, I think that's what you asked.
Yeah, we can apply many different areas. Finance, for instance, for classify a customer or classify people, which one people like more specific filming, for instance, streaming. So they apply in many different areas. Or for now, by COVID, they can classify which one in medicine, which one's image is, for instance, COVID or no COVID. They can classify, divide this in the group, use these algorithms, right?
Yes. May I show you an example in Orange? Okay. Let me share my screen once again. So I'm gonna open another data set. Okay, so we have this Titanic data set, and it's pretty cool. So we can, let's see how the features are, the variables. We have, for example, The people who were in Titanic who survived, yeah, and we have only the two classes, yes or no. We have the status of the, I don't know how to say this in English, but it's economical status. And we have the age, if it's an adult, a child, and we have the sex, male, female, and these are, let me check this one. These are, we don't have tags here, but I think, em qual a senhora acha que se encaixa, professora, o dataset do Titanic?
Titanic problems look like a prediction. There you see which one people, for instance, will survive or not survive, which one group people is priority or no priority. These are social problem or
Social,
accident,
yes.
or
Exactly.
it was one accident. So maybe social, don't know, but it's a prediction. This is prediction.
Okay, thank you very much for your answers. And no sé si alguien más quiere hacer alguna pregunta, por favor.
Sí, justo tenía ahí una pregunta que quería hacer. Good afternoon. I want to ask you some question. In the first, I want to do this was very good workshop, and thank you for your explain this topic, because it's very important to when we introduced to analytic data. Sometimes we know where I begin, and your workshop is very important for this. When some mother asked me if possible analytic data not only for marketing or network, if possible to logistic transportator, translator logistic for the big factories or other business.
In logistics, in business, is this?
Yep.
Yeah, it's possible as well. Can you remember one example, Alana, about logistics? Is
Sorry, my microphone.
For example, the transportation logistic in some like Amazon, like Mercado Libre or other business.
yeah. Look like one, in this case, is recommendation system. For instance, I remember one example. One lady was pregnant and don't want to show or see show for family. She wasn't pregnant already. I remember this example, but she looked like Amazon, many stuff for baby, and Amazon or a marketplace, I don't know exactly which one, but send for the house one gift or advice for baby, and say, oh, this can help you for your pregnancy. So, and she was really scared, the family discovery. Yeah, because if they classify as well, this is one group segmentation. When you see, we know when you see one shopping, and one shop you choose, and they show another one similar for you. Or it looks like the same. This is a recommendation, but you can apply this algorithm as well. Or Netflix stream. We know when watch one film, they recommend another one similar you did before, etc. Yeah, this is machine learning.
Thank you for your answer.
Thank you.
¿Alguien más tal vez tiene alguna otra pregunta? Okay, we want to talk. We want to thank you for your participation, Dr. HIEDA and Engineer Alana, in ESA Talk 2022, and we hope to have your presence in future events that will be organized with UNACH in Ecuador. So thank you very much, and we are very grateful with you and your participation. Gracias a todos por su participación también. Nos veremos en la siguiente conferencia.
Thank you.
Thank you.
Thank you very much.
Thank you very much.
El proyecto de investigación InfoProject y la carrera de Ingeniería en Tecnologías de la Información de la Universidad Nacional de Chimborazo, Ecuador, te invitan a participar en Second International Congress Innovation Research and Technology in Information and Communication Technology, ICTAR 2022. Evento virtual a realizarse del 21 al 25 de febrero del 2022. Para más información, visita nuestra web ictor2022.unach.edu.es. La Dirección de Posgrado de la Universidad Nacional de Chimborazo oferta el programa de maestría, Auditoría de Tecnologías de la Información, una maestría académica con trayectoria de investigación dirigida a profesionales con títulos de tercer nivel en áreas como sistemas, informática, tecnologías de la información y otros campos del conocimiento relacionados con las TICs. Ven y sé parte de la maestría académica con trayectoria de investigación, Auditoría de Tecnologías de la Información.
La carrera de Tecnologías de la Información surgió por la necesidad de contar con profesionales que ayuden al desarrollo sustentable de la sociedad en el campo de tecnologías de la información.
Estudia los principios, metodologías y estándares de calidad involucradas en el proceso de análisis, diseño e implementación de las tecnologías de información en un organismo institucional, en las áreas como son redes, programación, infraestructura, seguridad, base de datos y servicios web, lo que contribuyen al desarrollo productivo, local y nacional, así también como el acceso universal a la información y comunicación.
El objetivo de la carrera de Tecnologías de la Información es formar profesionales éticos, competentes y emprendedores con conocimientos prácticos y teóricos para diseñar, implementar y evaluar soluciones de tecnologías de la información. Otro de los objetivos de la carrera es permitir el acceso al conocimiento científico que es necesario para desarrollar las competencias profesionales que contribuyan al desempeño laboral en las áreas de redes, programación, seguridad de la información, infraestructura, desarrollo de software y aplicaciones web.
La Universidad Nacional de Chimborazo nos brinda varios servicios como son el uso de laboratorios y equipos de última tecnología, acceso a la plataforma, aula virtual y biblioteca. Tenemos también áreas verdes y espacios de recreación. Un servicio adicional, contamos con un incentivo a los estudiantes que obtienen el primero y segundo lugar al culminar cada semestre con las mayores notas. A eso lo conocemos como son las becas académicas.